Okay, so good morning. We are trending towards good afternoon anyways. So today we are going to talk about Intel hardware and the software development kit on IoT. Anybody don't know IoT? Okay, cool. So you did. I was planning to save about 5 minutes, so now I have to spend a bit time on IoT. so internet. Anybody don't know about internet? Yeah, you know, right? So Internet of Things. Excuse me. So is a full form of IoT, right? So internet, we know. What is things? So what are things that we can think of? Right? There are a lot of things. Can be a smartphone, it can be a chair that you are sitting in, it can be my laptop, or it can be anything, right? So if you build an internet, if you can connect them within a network, that becomes an Internet of Things. Correct? Very simple. Internet of computers were there, right? Over a period of time, Internet of computer and human being started when we started getting into all these wearables and stuff like that. Now Internet of Things, right? You are trying to make everything talk to you and make your life simpler or better, right? That's where the Internet of Things is going, and that's exactly the primary goal of Internet of Things. Now today what we are going to do, right? First of all, let's quickly look at what hardware is available. There are n number of hardwares available, but we'll focus on the very important one, and then we'll move on to what Intel is offering in that space. Then we have software kit we are going to talk about, and I'll show you. So my session is going to be maybe first 15 to 20 minutes at the max I'll spend on talking through the slides. After that, everything is demo, right? I'll go through the demo completely. We'll try and maybe I have to speed up a bit to cover all the demos that I planned. Okay, feel free to stop me for questions. Okay, if the question is going to take a long time, obviously I'm going to say that I'll cover it at the later stage. Anybody heard about Arduino board? Yes, it's a very famous prototyping board available in the market. Right? There are tons of amazing projects that people are developing using Arduino. It's very easy to use, and it is you have tons of information in the internet which you can simply copy paste and start developing your Internet of Things application. Okay, so some of the if you go and look at let's say Instructables, and you search for Arduino projects, you get great ideas, right? What kind of application that people are building with Arduino is what you can see. Okay, and how many of you have developed an embedded or Arduino based application? Okay, quite a few, right? So for those others who have not developed, right, I would request you to just search in Google by say like Arduino projects, and see what kind of project that you get in the market. It is very easy to pick up. You know, if you are thinking like, how do I get into IoT? My suggestion is first try Arduino. Get into Arduino first. It's very easy. You get tons of resources online. Play around. I would tell you, for the people from the software background, right? You might take a month, or at the max 2 months, to pick up the whole concept of the embedded development. Of course, you may not be able to understand everything about electronics and stuff like that, which is not our primary strength. But overall, how the architecture is, and how can I start developing an application, embedded application, is very easy to pick up. So personally, I'm a web developer. If you see my bio, right, it's all about web and Windows kind of application development. But when I moved into IoT, in 2 months, I started writing samples, and we started uploading it into Intel websites. It's not because I am a genius, you know. It's not because of that. It's because of the simplicity of the hardware and the software today. So just to name few of the examples that we see in Arduino, right? If these pictures I have taken from Instructable. If you look at some of the examples, there is one project that people have developed. It's like they put an Arduino board in the shoe, and imagine like I want to go from here to, let's say, Majestic, right? They put this 2 vibrators in both the legs, shoes primarily, and they take a mobile phone and they set the direction, saying that from here to say Majestic. They set it and they sync it with your Arduino board, and that's all. They keep the mobile back in pocket. When you are driving, right, it will start vibrating the appropriate leg or the shoe based on where you have to take right or left. If you have to take right, it will start vibrating the right leg. It looks very fancy. It may look like, oh, okay, something great they have done. If you go and look at the code, it is like our getting started kind of code that we write, right? When we start Java or when we start JavaScript or anything like that, only that amount of code will be there, right? So it is very easy, is one thing I wanted to bring in. The other one, you see that skateboard, the boat, sorry, what you call skiing or whatever, right? I don't know the exact name. The flip board or whatever, right? So there, what they are doing, it's for training, right? If you want to train somebody, right, you need to know how you can maneuver that whole movement, right? So that is very important. What they have done is they just put a small board below Arduino board below this particular flip board, and it keeps sending your angle, like how you are moving, based on accelerometer values, right? As simple as keeping a mobile phone below the board, and which keeps sending accelerometer values, right? We know how to develop that kind of applications. Similarly, if you look at it, there are tons of amazing applications that people are developing on Arduino. We can live with Arduino if your application is very simple. Okay. Now, if I come back to the specifications, right, there are other pins and all I'm not going to talk about. The one important factor is the processing power. We are talking about gigahertz. This is an embedded in the embedded world. They are talking about megahertz, and that too 16 to 32 megahertz processor or the microcontroller. Can I even imagine doing something like image processing or something like let's say audio processing and those kind of things? The moment you see that kind of problem or that kind of use case, the processing power will limit your imagination. You cannot go beyond that level, and you will start thinking about, okay, let me take a picture somewhere, have a cloud or have some other system who will recognize or identify the face and then send the information back to your board, and then do some processing on the board, right? It's all becomes very complex. Looking at this scenario, right, Intel came up with, because we are always ahead of curve in terms of this processing and other things, right? The first thing that comes to pretty much everybody's mind when they say Intel is processor, right? It has been like that, and we want to be in the leading position in that aspect. So with that perspective, right, Intel introduced something called Edison. Have you heard of Edison before? Okay, quite a few hands. So Edison is basically a dual core atom processor based board, right? Like how you had the other board, this is a dual core atom based x86 platform board. Okay, this can go up to 500 megahertz. In the Arduino we were talking about 16 to 32 megahertz. Here we are talking about 500 megahertz dual core processor. Okay, and it has inbuilt Wi-Fi and Bluetooth. So I can do inbuilt, I can even interface with any of the external boards and things like that, right? So in Internet of Things, communication is very important. Enabling communication is very, very important. So primary communication protocols we have today are Bluetooth or Wi-Fi, right? So both of them are already inbuilt into it. It has 1 GB of RAM, and it has got 4 GB flash, okay? And I'm not talking about the Arduino board or the size of the Arduino board. So maybe the size of Arduino board is this one, this big, and the Edison is this one, okay? So whatever I talked here is this board. So now you can think of a wearable which is of 500 megahertz, okay, which is a watch, it can be a locket, anything, right? And you can even do easily you can do image processing. I myself, if you go and look at videos in YouTube, I myself have some of the videos which talks about how do you do face recognition using Edison board. Because of the processing power it has, it's very easy, right? Very easy to do. And again, it is x86, right? So what we are providing from the software perspective is a Yocto Linux, which is x86 based Yocto Linux distribution that we provide, which you can flash onto this, and you can even install even if you, since it is a Java thing, right? If you want to install JDK, you go ahead and install JDK. If you want to do C++ programming, do it. If you want to Node.js, do it. Every support is available, right? Plus, since it is almost like your laptop, right? So this 500 megahertz, like if you look at 10 years back, right? 500 megahertz PC used to be this big, and today this is the size. It's exactly the same thing. Okay. Now we have this expansion board, right? For people who know Arduino, right? They will understand this. So you cannot simply use this board as it is unless you build the expansion for this, right? So for example, if you want to interface with, let's say, these lights, you have these 70 pins at the back, but you need something to expand it further so that you can interface with those pins, right? That's very important. So for that expansion part is open source. We have enabled, we have published all the related files, everything. People can go ahead and build their own expansion boards. Like for example, SparkFun and all is building very, very small expansion boards. The one that I have here is the Arduino compatible. Okay, since Arduino is quite famous in the market, there are a lot of additional expansion shields that are available on Arduino, and we want to take advantage of those shields already in the market. So this expansion board will simply expose all these 70 pins into these other pins that you see on the other side. These are all digital I/O pins and digital and analog I/O pins that you can see. Now, the moment that gets exposed to this Arduino compatible expansion board, any Arduino compatible, let's say it could be Wi-Fi shield, or it could be a GSM module where you want to send an SMS or call somebody from Edison or anything like that, all of that becomes very, very, very straightforward. Okay, I do have an expansion here. I'll show you when I get into the demo. Okay. So that's the Arduino expansion that I just talked about, and you have another thing called Edison, mini expansion board. So if you look at the size here, right, so this is the regular expansion what I just showed you. This is the mini expansion, which will be of this size maybe, right? Wherever you have a real estate problem, right, where you don't have enough space for your devices to be kept, then you will probably go with the expansion board like this. And the companies like SparkFun have built even better expansion board, which may be of, I would say, just a little bit bigger than the Edison board. So if I show you here, I forgot to bring it today, right? Maybe their expansion is only of this size, up to this. You know, that kind of expansion boards are available. The other one is Intel Galileo board. So this is again, this is based on Quark processor x86, and it has again it has 400 megahertz processor in it. It's a single core, single threaded processor, same as Edison board, but this is like this one you cannot take out Quark processor out of it, right? That's what the primary difference is. Okay. Can you guys see this? What this side? No? Anyway, I'll quickly talk through it, right? So in the past we used to give like processor, we used to sell processor or motherboard and things like that, and we never really cared about developing some kind of SDKs or things like that, right? We are not too focused on it. But now in the era of IoT and other things, you need to have proper SDKs, right? The developer kits where people can take advantage of it and start developing applications right away, right? That's what we have done, and that's what this IoT Developer Kit is all about. In this whole picture, except the boards, right? Except the board, everything else is either free or open source. Okay? All the tools, all the SDKs, everything is free, and we have made sure we used an open source applications to build the intentionally we used open source applications so that community can add on to it and then build something if they want to. So here are the two hardwares, of course, Edison and Galileo. And as I was telling you, we are building Yocto based Linux distribution. And again, BSPs, everything is open. You can go ahead and if you want to build your own image, Linux image, you can go to yoctoproject.org, take our BSPs, cut down whatever is not required and build very lightweight Linux image if you want to. Okay? And by the way, we don't want every developer to do that tedious task because it takes about 8 to 10 hours to build an image. So that's why we are providing an image which already has support for Node.js, Python, C, C++, right? And of course, if you want to have Java support, you can add it on top of it, but right now it is not there. You can go ahead and download JDK and then add support to it. That's our libraries you can are exposed. You can go ahead and use like our C, C++ binding and use with your Java applications if you want to. And we don't want our developers to use a notepad or that kind of tools to build their application. Right? We want something like an integrated application which helps you to build your application and also test, debug on the board directly. With that intention, for Node.js developers, we are providing Intel XDK, which is, we have an IoT edition for that. We are providing that, which is free downloadable from software.intel.com. Have you heard of XDK? Yes? It is, I think last year, in Gits only I spoke about it. It is mainly, it was earlier focusing on cross-platform application development or hybrid application development kind of platform. So now we have expanded that to IoT also. Right? Now with the same tool you can build an IoT application which runs on the server, and you can build a client maybe which runs on your mobile device which can control your IoT device. So it's all connected, right? That's the XDK. Have you heard of Eclipse? Yes, Java. So you should know Eclipse. So we have used Eclipse. We have added our own plugins or whatever, right? And with that, you will be able to develop your C, C++ application and test it on the board directly. Okay. And we have other support, like if you go to videodrain.com, then you can register your board, and like a Lego blocks, you can drag and drop the whole program. It keeps creating JavaScript or Python code for you, which you can directly push from the cloud to the board, and you can test everything on the board itself. Of course, Arduino IDE is there. And finally, we are giving you a free space on cloud, enableiot.com, which is Intel IoT Cloud. You can push your data to the cloud, or you can even actuate, or you can even control some of the ports or the pins in the board through the web. Right? That's a free space available for you to try out. And of course, it comes with the developer program, We have a developer kit and we have a developer program which you can participate as a, like if you want software downloads and all those things, you can go to software.intel.com/IoT and download. And there is a forum where a lot of makers across the globe are actively working on Galileo and Edison and providing feedback very frequently, right? If you post a question, some or the other, like if you go and look at the forum today, you don't see, I would say at least 80% of the questions are answered by some or the other, right? Maybe 20% if you are unlucky will not be, but most of them are answered. And we do conduct roadshows. So last month we had IoT roadshow. We invite application for that, and when people come in, right, we give away Edison and a sensor kit like this. It's like a hackathon. In 2 days, people develop applications by learning from very basic to a complete project. So they do it in 2 days. Okay. Last time when we had our roadshow, we had about 150 people. They developed about 41 projects. Okay. And when they complete, they will be posting all of their concepts into Instructables. That we keep doing it. And the next one is in Pune. Right, it's happening, and soon we will be opening a registration. So keep an eye on software.intel.com/IoT. When the registration opens, you can submit your idea, and then we can take it forward. And we do have a university program where we have distributed about 1,000 to 1,000 universities. We distributed about 50,000 odd Galileo boards and things like that. Of course, you can go and join our online community to know more about things. So the cloud part, so most of the people get confused between an embedded application and an IoT application, right? So people think that I developed a small gadget and I start calling it as an IoT application. Right, there is a very thin line between between multiple terminologies like this. We have embedded, we have M2M, and we have IoT. You know M2M, machine-to-machine communication, correct? So embedded application it can be anything, right? It can be something like controlling your fridge temperature. There's a small application sitting there which is doing that job. But that is not an IoT yet. If that controlling of temperature is synced with, let's say, some cloud, and you are trying to get some insight into your power consumption or varying temperatures in the fridge, or if it is telling you that, okay, whatever the internals of fridge is going bad, you need a service repair or something like that, right? If you connect to internet and if you can get an intelligence out of it, then that becomes IoT. Till then, it's only an embedded application. Same with M2M. The biggest confusion is between M2M and IoT. Machine-to-machine communication and IoT, right? So if you dig a little bit deeper, right? So you are actually controlling something from a different machine. For example, one machine is controlling another machine or communicating between the two. That will not become an IoT. It should be something like you should get some insight out of the things that you are doing. Then it becomes an IoT application, right? So for doing that, the cloud will come into picture. Now you collect data, you submit to the cloud. Based on the pattern, you will probably change the way you use those devices, or you will let the machine learn different patterns or different activities based on the past information that is available on the cloud, right? That's how the whole thing is connected, and this board already comes up with all the necessary software to communicate with Intel Cloud. Okay, so we'll probably try and go into that as well in the demo. So let's start with a simple hardware setup here, right? So now on, it's only demo. Okay, so I'll take my seat. So it's basically a 3-step process. First is, I have my expansion board here, right? So this expansion board is right now it is standalone, right? It is, let's say this is my board, this is my expansion board, right? They're all lying separate. Now I need to first marry these two, because I have a Edison which, if to expose their pins, I need to have an expansion. So first I'll do is, so if I see here, there is this 70 pins here, and there is a slot for that below. Okay. Now all I have to do is put it like this and press. Okay. Now Edison is mounted on my expansion board. Step number 1 is done. Now I need to communicate with my PC, right? Initially I can do it through the wires. I can even go with serial communication or with different communication methods. For that, if you look at here, there are 2 ports available. This is for serial communication using COM port and all, right? You can go ahead and do the communication. This one is used for multiple things. One is to update firmware, one is to power up your board, right? And other thing is like you can even push Arduino code through this port. Okay. And one more very important and very useful feature is that when I connect this, I can make Ethernet over USB kind of communication between my laptop and the board. Every board will have a static IP of 10. I think 192.168.2.15. So I can make pings to that, and then I can communicate with the board. So let me power it up. The other side is going to my laptop. So I'll power it up. Meanwhile, there is a small switch here. Okay, just for doing basic things, you can switch it to draw power from your PC. But the moment you want a bigger sensors, which consumes more power, right? Then this is not sufficient. Then you switch the board or the power to the right side, and there is a power jack here which can take 7 to 12 volts or 15 volts power. If you put a power jack, then you will be able to use any of those. For example, if I connect a camera to this USB port here, let's say webcam, power what I get from here is not sufficient. So then I need to power it up using the external power, right? That's how the whole thing. And if you look at the board, these are all the digital pins. These 6 are analog pins here, and these are all the power pins. I'll go into what is this analog, digital, and all the details at a later point. Okay. Okay, so now when I do this, I don't know how you can see this. Okay, there is a green LED that shows the board is booted up. Once this part is done, now it's all about communicating with the laptop. Like any other, let's say you are developing an Android application. The moment you connect Android to your PC won't recognize that, right? It won't recognize immediately. You need to have drivers. Same thing applicable here also. You need to have Intel Edison drivers, which can be downloaded from our website. Install it, then it is ready to make the communication. Okay, first step is done. Now if I go to, let's say, so there are some steps involved in order to make this 192.168.2.15 kind of communication, but I'm not going to go into that. It's a simple network setting that I need to do that. So I'm able to communicate, I'm able to ping to the board. Now, as I was telling you, there are multiple tools depending on what language that we want to use. Okay, so the language that I will be using, right, is, let's say I will first use C++. I will just run one program, then I'll switch to JavaScript and show you everything in JavaScript. Okay, so for that I'll go to Eclipse. We get this Eclipse downloadable from our website. So once you get your Eclipse, this is the primary interface what you are going to get. Okay, on the right side you have an option to create target connection. When I say create target connection, I'm connecting my Eclipse to the board over that same IP address what I talked about, fixed IP address. We need to have an IP address to push the code. The code pushing won't happen over serial. Okay, that's one thing. Now I create a project. Let's create a simple project. So when I open the project, right, when I go to create a project, I get different templates. So basically they are samples. You can take any of the samples, and whatever necessary configuration for that sample is already done, you can start running the application right away. So let's go and use the simplest one, onboard LED blink. In software world, right, your first project is always going to be hello world, right? In embedded, the first project is always going to be blinking LED, correct, right? So I will we'll follow the same. First blink is my LED, then I'll go to next. Since I have already communicated that whatever the previous connections are retained, so I'm just creating a connection to that. I'll say finish. It takes a bit time. Okay, so now it created the project for me. This is the first blink LED, and it also created the respective debug configurations. Okay, and it also have created the configurations for run. Now all I have to do is select the configuration. Then this is going to push the code onto the board. Okay, now I'm right now I'm on debug mode. Let me go ahead and run it. Before that, let me show you what's happening on the board. So if you look at it, there is actually no blinking or nothing happening right now. Let's switch back and see if it starts blinking. Okay, so you see this light blinking here. Now how this magic happened? Okay, so I didn't talk about what code I have written and nothing like that, right? So let me just quickly show you what code that I have written in this case. Switch here. So it's all C++. Now if I expand it a bit, so I have this GPIO. Okay, so there's a class called GPIO, there's a class called AIO for analog input output, GPIO for digital input output, I2C for every IO we have a class, right? And I'm using GPIO in this case. And then pin 13, so mine is Edison, right? Pin 13 is the number or the digital number that is connected to that blinking LED. So I'm going to initialize that pin 13. After that, since it is blinking, so the power is going out as an output, right? So I need to set it as an output parameter. So that's what I'm doing here. Set the direction as direction output. Once that is done, it's all about setting high or low voltage. So that's the one done by 0 or 1. If you look at it, there is an infinite loop with a sleep in between. All I'm doing is write 1 or 0 after every second. That's all the code is. Okay, the blink LED is working. And same way, if you download this tool, there are other samples on analog and all. You can go ahead and use it later. This is one tool. If the reason you might want to go with Eclipse is that if you are building a complex project, which has a lot of dependencies with external libraries and things like that. It's easy to build it with Eclipse than building it on Arduino or anything like that, right? So that's the primary intention of providing Eclipse as a development tool for C++ developer. Now the other thing is our favorite XDK, right? How many of you know JavaScript? Perfect. So I think you will love this part of the demo. Now this is the XDK tool. Okay, when I start an XDK application, right? So when I get a new application, first time when I start with a new project, right? I will do the same blinking LED first, then we'll go to the other examples what we want to do. So when you start your project, if you see there are two sections here. The first one is Internet of Things. If you can't see that, I can probably zoom it. You can see Internet of Things templates, and the other part is HTML5 companion templates. The first part is primarily, it's like the code that is going to run on the board, on Edison board. The second part is the one that is going to run on your mobile devices or tablet or any of those devices, which can communicate with the board for various reasons, right? If I want to control, let's say, water, if I want to put water to my plants, I want to control that particular pin, so that I can do it from my mobile phone. So that's what two templates are available. Okay, so now before getting further, right, I didn't show you how the board itself look like, right? So let me go into the board. I'm using putty here to make a serial communication with the board, or the SSH communication with the board. If you see, root is the login, and I'm giving the IP address as 2.15, and 22 is a port number for SSH. Now what I can do is I can open a putty connection. I don't know whether okay, you can see it. So that's my Edison board. Okay, I'm logged into the board. Now if I go to go to the various Linux commands, it's a pure Linux board, right? It's x86 board. Now, so that's based on Yocto Linux. Okay, so from here, so if you see where my blinking LED went when I ran it from Eclipse, right? I can go to /temp. Okay, you can see first blink here. When I ran it from Eclipse, it pushed the code to the temp folder, and I'm able to run it from here. So even if I want to run it from here, I can say /. Okay, what's the name? Oh, okay, sorry. So even now, if I go back here, the blinking continues, right? So if you after application development, if you want to run it separately, you can go off and then start running it separately, right? That's what I wanted to show in this part of the demo. Now let me stop this. Okay, LED stopped. Now I'm back to XDK. Let's pick one template. I'll go to, let's say, again onboard LED blink. In this I'll say continue gits LED blink is a name. Go ahead and create. Okay. Now the code is this much. So again, like how I did in C++, I'm creating an instance of the GPIO. MRAA is the library that we are providing. So I'm doing require, or I'm loading MRAA library first. Okay. After MRAA library, I'm initializing GPIO 13, and I'm starting a periodic activity, which is a simple function with set timeout in it. All I'm doing is, based on the state, I'm writing different like 1 or zeros. I'm actually alternating 1 or 0, and since it is set timeout is every 1 second, same effect of blinking LED I'll get from JavaScript also. Now this I can do it in Notepad also. Why should I need XDK, right? The value of XDK will come now. I'll show you what we can do with XDK. Now you see this part, IoT device. I can go ahead and connect to my XDK, see, to my Edison board. So I can give user ID, password, SSH and everything. I can connect to my board from here. Now I already connected. So let me go ahead and select that part. Okay. So since the board already has Wi-Fi, I don't have to do it in wired way, right? I can even connect to Wi-Fi and push the code over Wi-Fi to the board, right? That is also possible with the board. So now I'm connected. Now I can go ahead and synchronize the time between my PC and the board, because board doesn't have any battery, right? So that means the clock will be reset. If you want to explicitly maintain the battery, then you maintain the clock, then you need to have an RTC, right, real-time clock there, which can help you to maintain the battery. Now I'll sync the date and time with the board. Okay, here at the bottom it is saying it is synced. The date and time is synced. Now there are other options. I can even do SSH from here itself directly, or I can do a serial communication with the board. All of them you can do it in one tool. You don't have to go out of this tool at all for doing your activities. Now once I'm ready with the code, right, so all I can do is like I can go here and upload the code to the board. So you notice that when I clicked on this, it uploaded that JavaScript onto the board. After that, let's assume you have dependency with some, let's say, socket.io or any of those external NPM modules. You can specify that in a JSON file called package.json. If we have mentioned anything in package.json, then when you click on this build, it's going to download those packages directly onto the board and install those packages for you. So you don't even have to get into the board to do that npm install and whatever the libraries, right? It's all done automatically from here. After that, it comes to the running part, right? Here two options. One, I can directly run the application, and the second one here is to debug. In case if you find some issues, right? If you develop in Notepad, you cannot debug unless you have a lot of console.logs to see what is going on. Here I can do step-by-step debugging of my code and find out where exactly the issue is. Okay, and here this is the run option. I can start the application directly from here. It says application is running. Let's see whether it is running or not. See, the same blink LED is running here. Ultimately, the code part, from a code perspective, everything ultimately goes and runs the same C program, but these are all exposed to JavaScript, Python, and all the different languages. Depending on your choice, you will be able to go and use whichever the language you like. Okay, now let's see, try and build something relatively interesting. I have a half-baked example here, so we will build that application and see how the whole thing works. Okay. Meanwhile, all the samples that I have taken are from software.intel.com/IoT. If you go to this website, you see examples on everything that I'm going to talk here. Okay, every sensor, we have about documentation for about 80 odd sensors. So you can simply go and straight away copy and paste your code and get started. Okay, if you see here, this is C++ part, and at the same time you have a JavaScript part. So we have examples in C++ and JavaScript for each and every sensor that we can support. Coming back to XDK. Now, so blinking is okay, right? So let's make little bit more interesting than what we have done so far. So now I'm going to push an expansion board here on to the board, onto Edison expansion. Okay, so that's it on the expansion, and I have a lot of these sensors and other things connected. So I have one button connected here, there is one buzzer connected, there is an LCD display connected to this, and I have a temperature sensor connected to this. So all of them are connected now. As a pre-work, I pre-connected everything and came here. Okay, now so what we'll do, let's build a simple calling bell, right? Or you press a button, it should make a buzzing sound, right? Let's build that first. For that, I of course need MRAA library to actuate, and I also need a GRU library which will have access to all these buttons and other things. Okay, I have let's start. Okay, now let's take this part. So what is it doing? I'm actually initializing a GRU button class which is on port number 2, and in an interval every 1 second I'm looking for the latest value, is it 1 or 0 of the board, right, of the button. That's all I'm doing. Let's see if it goes through fine. Let me save this. Upload complete. Let's start. Okay, now I have this console log coming in at the bottom. Let's see what happens if I press the button. So you see that it started showing 1. That means the button is pressed. If I remove it, it becomes 0. So 1 is on, 0 is off, right? Like how software also does. So let me stop this. I didn't achieve anything yet, right? I'm just showing what numbers are coming. Now let's start making some buzzer sound after this step. So for that, what I'll do, I'll take some more amount of code. In this, let me replace this part with a buzzer part. Okay, now look at this. This is the second set of code. I have a buzzer. Buzzer is just an output, right? It's blinking an LED. Instead of LED, I'm connecting a buzzer here. So a GPIO is 5. I'm connected to 5 GPIO. Type is output. So apart from writing the value, I'm also seeing button value. If it is 1, then buzzer dot write 1. Okay, so it is going to make a buzzer sound when I run this program. So let me run this. Sorry, not this. I'll have to upload the code every time I make the changes. Okay, now see if it browses. You can hear that, right? So it is making a buzzing sound whenever I press the button. This all looks good. So in the meantime, what we have learned so far is digital input and output is covered, right? The button is a digital input, and buzzer, what it is giving out, is a digital output. That's all we learned so far. Okay, let's move on and see if we can do something with analog. For that reason, I have my temperature sensor. What I'm going to do, now I'll put this temperature sensor. Okay, I'm going to read the temperature values here. Instead of making the buzzer sound based on the temperature, based on the button, I will now make a buzzer sound based on the temperature. Okay, I have 5 minutes left. I need to go a little faster here. Sorry about that. Okay, this code is quite simple. There is a GRU temp, and it is connected to analog 0. Now if I switch back here, these are all analog pins. Okay, this one, so these are all analog pins, and I have connected to 0, and that's the temperature sensor. Okay, let's see how it goes. Now all I have to do is take the value every 2 seconds. That's what I am doing. Now let me push the code. Then I'll okay. Now it started running. I don't know the temperature. Let's see. If the temperature goes above 31 degrees, right, it's going to throw. It's going to start buzzing. It's not buzzing, and I don't know what temperature it is right now. Okay. So what we will do, we want to see the temperature, right? So how do I see the temperature? I can do console log, which is a traditional way. For that, I have to be connected always to my PC to see the log. Rather, let's do a display, right? I'll show it on an LCD. Okay. Let's see how that can be done. Okay. So I'm going to put that whole code back here due to the time constraints. Okay, not much changed. There is an LCD class added. Okay, LCD class added, and I have a do temperature, read the temperature value, and set the color for LCD, and write the temperature value onto the LCD display. Correct? So I'll save this. Let's go back. I'll push the code, run the value, and see what is the temperature. So it is about 26 degrees centigrade is what it's showing. I don't know whether this display will, you will be able to see the display properly. You can't see the text out there. So if you come later here, right, I can show you the text. So now what we'll do, we'll make a bit of tweak to the code so that at least I can show you something on the color changing and other things, right? Now I'll upload. I've made it as 28 degree. At home it was 31 degrees. So let me do this. Okay. Now I'll increase the temperature. So now if you see it started making that buzzing sound, and also if you can notice the color of my LED changed to red. Okay. Till now it is only, okay, that's irritating. Okay, so till now it is only an embedded application. Now we need to make it an IoT application, right? So how do I make it an IoT application? If I start sending the data to cloud, and if I can track something on the cloud, then that might become an IoT application, right? For that, I'll have to do a couple of things here. As I said, we already have the necessary libraries. So I'll go ahead and put it here. Now, in this loop, I'm going to send temperature data, right? Every time the data changes, I'm going to send that temperature data to the cloud. Okay. Okay. So my board is not connected to the same Wi-Fi, so it may not send the data. But I'm going to show you only the code that is required. All I have to do is like send the observation, and I use the datagram packets using UDP. I can send the data to the cloud like this. It's just a key and value pair. I have to send it, and if I go to cloud, I'll get a dashboard like this, right? I can register everything. I can register all the values and get the dashboard. Apart from that, I also have something called alerts. If the temperature is more than 32 for an extended period of time, it might give me an alert like this, saying that you have I mean, it will send an email, or it can even actuate certain other aspects from the cloud itself, right? That shows a connected end-to-end solution where you start with an embedded application, then you connect to the cloud, and you can communicate with the cloud without any lag, right? So that's primarily what I wanted to cover. Another maybe 5 minutes would have been better, but anyways. So if you have any questions, anyway we are going to share these slides, so people you can go ahead and use this. Pretty much everything is covered in this. If you have any questions, you can ask me now, or you can tweet with my tag to me. I'll be very happy to answer on Twitter. Okay. Thank you very much. Thanks for your time.